Hey, what's going on, everybody? Today is January 9th, 2025. You're watching the Daily AI Show live or listening to it. Welcome. Glad you're here. Today, we're going to be diving deep into NVIDIA's recent CES announcements. There were multiple of them. Some of them overlap each other. Obviously, this is an AI show, so we're going to be focusing on that to really dive into it and help you guys understand why what they announced, what Jensen Huang announced, is important. Where we think it's going, how it can impact, future AI initiatives. I think there's a lot of that. So I have Beth and Andy, and I'm Brian, and Karl, who just joined us as I said that. So welcome to Karl. And yeah, I think I was saying to you, Beth, right before we went live, I said, this is it's not tricky, but there was a lot announced. I was reading to you and kind of joking that I have notes on the side here. And if I just read for the next 30 seconds, I could just name names like Thor and Groot and Cosmos and AGX, and I could go on and on and on. And so, there's like you said, well, we're not shooting for comprehensive here. We're shooting for just a good conversation about what was announced, what's really interesting about it, and how NVIDIA is just wrapped so tightly into the future of AI in general. So that's kind of where I think we start the conversation. Now, Andy, I know you had mentioned Cosmos. That was one of the things mentioned. I don't know that we have to go in a particular order here, but I think personally, I found that announcement, that part of it, really, really fascinating. And it goes into the idea they'd already talked about the Omniverse. It talks about digital twins. And the way I understood it, and God knows you guys correct me on this one, but the way I understood the Cosmos part of it was you create basically digital twins. Let's say you have a factory floor, you create a full factory, and you create a digital twin of that, but it's going to look non-rendered almost. And then this Cosmos allows the real world, the world foundation model, which is a model like we know ChatGPT to be a model. And that basically brings it into a real life scenario. So they were showing in videos where it was very gaming looking. And then right next to it, they said they process it through Cosmo, and then it looks real life with real shadows and stuff like that. I found that really, really interesting. And Jensen Huang said, in the future, all factories will have digital twins. And I just thought, wow, that's a profound statement to think about that. So I don't know. It's a place to start. We can go other places, but I'm trying to wrap my head around this, talking out loud about it. And so I'm curious to hear what you guys thought, because there's just a lot to sort of digest here in this big announcement from CES.
Yeah. So Cosmos and Groot, the sort of companion system inside the NVIDIA larger ecosystem, are both around robotics and autonomous vehicles, and they work together. Let me just describe what Groot is. Basically, it does things like synthetic motion generation for the actors within the Cosmos, right? And this is designed for humanoid robot training, particularly. And Cosmos would give you the platform in which you can build the specific environment for which you want that robot to be trained. So they're building models, and they're also building platforms like Groot that allow people who are doing autonomous deployments to build the system that can train those actors. I'll call them robots. But in digital form, they're not robots yet. They're basically just learning the roles of the robots that will be enacted in real physical space. And this is part of Jensen Huang and NVIDIA's vision, which is all about physical AI. Like, how do we take what's so competent in digital and text? How do we convert that somehow into physical environments where we have AI operating?
Yeah. Sorry, I was pausing to see if Beth or Karl could come in on that one. Yeah, I think that's the gist I got of it. I think that's a good explanation of it. He talked a lot about synthetic data, and it's sort of synthetic data I felt like was wrapped in a theme almost. If we were going to look at a ribbon going through this whole presentation at CES, I felt like synthetic data was a lot of it. And he talked a lot about how it's hard, it's costly to obtain real world data on autonomous vehicle or on any vehicle for that matter, and how that has to process. And there was also Thor Blackwell, which was looking at my notes for auto processing, which was the chip that sits on the vehicle and processes. He was talking about all the cameras, but above processing, and he was saying how that's costly. He talked about how taking these hundreds of maybe hours of real world cameras and processing and turning that into billions of synthetic reenactments, I guess, maybe, or processes where they even showed in one of the little videos, like for the outlier type use case, and it's a car going down the road and there's like a black bear on the side of the road. And I was like, yeah, that's an outlier. That's not going to happen every day to everybody. But I guess the point was, hey, if we're able to turn this into synthetic data and the different things that we're talking about, we can plan for all essentially eventualities, and that synthetic data then makes it possible for autonomous vehicles to have their next moment to truly become autonomous, because they're not just relying on a million Teslas driving a million more miles. Essentially, that was the gist of what I got. But tell me if you think I'm wrong on that. Like, again, I'm trying to work on this myself.
That's true.
Well,
The,
hasn't well, I'll just point out, like, hasn't Tesla essentially been collecting that level of data for the
Sure.
past, I don't know how many years? Same with you'd have to assume Waymo is doing the exact same thing.
Yeah, Google.
Cruise
Yeah.
did whatever. Every single interaction, every single data point that has been driven. And what's interesting about Tesla is, even if it's stationary, it's still collecting data, right, with its cameras.
Mhm.
So I can only assume, at least from a Tesla side, they just have all the data and continue to collect data as more and more people buy Teslas and they do more and more things, more cars and so on. So can't they take that data and then create synthetic data off that data to have even more data? And
That's the impression
right.
I get. Yeah.
Theoretically, yes, right?
Yeah.
But XAI has all the data of Twitter as well. Like, is it possible to take it? Yes. And then we get back to the discernment, right? So what are you moving towards? And that, I find that really interesting in terms of the digital twin for like each position, because it seems to me that it kind of functions as the like, it functions like the individual agent, like we're seeing with the multi mixture of expert models, right? So there's, if we understand it correctly, there's like a stage manager agent that says you're on, so we're going to light up this amount of data because we're only interested in the digital twin for this specific thing, which then makes it more efficient, even though you pulled from all of the available, like black bear, something fell kind of information. You're still only using it for what is defined as that twin's function, what like arena in which it operates. Is that, are other people thinking that?
Yeah, I mean, again, you guys, I'm leaning on you guys. I mean, that's the interesting part of this conversation is like, where do these pieces and parts fall into the greater advancement of some of the AI areas we see, whether it be robotics, autos, laptops, right? I mean, that was another thing that was announced in two different ways. They announced, or three different ways, I guess. So they announced the RTX 5070, which is their latest enhancement in computer processing. It was like, I don't remember the stats on it, but it was like whatever, 10x or twice as fast as their 4090 performance. Right. Which I'm not like, I'm just not. I know it in terms of what I have in my laptop, in terms of what it can do for performance on my laptop. But as I was joking yesterday, I'm personally not a gamer, so I'm not as locked in, I feel like, on some of these advancements. But what I saw is that what impressed me on the graphics card side of it was they were able to hold on pricing pretty well, considering that one was going to be I think the bottom of the totem pole was $549, which is a reasonably priced card as things go for that kind of performance. And also that they were talking about how AI is largely responsible for its performance improvements. So, we were sort of talking about this yesterday. Somebody, maybe Andy or somebody else, somebody was talking about CES and maybe about a TV who was talking about taking old movies and making them better.
Andy.
Andy, yeah. So you're talking about upscaling, right? And so it's this idea that, we can now have like similar hardware, but by using AI, we can upscale. And I almost got that feeling with like this new processor. It's like, with AI, we were able to get 2x the performance out of it. It's still while maintaining the same price point, which you don't typically see. And then, of course, we'll talk about the laptop. There is a 5070 laptop, by the way, that's like $1,300, not to be compared to be confused with
let's
digits.
make that distinction between the GPUs that are being added to PCs and the announcement of Project Digits, which is this GB10 Grace Blackwell chip that will be a CPU.
Right.
That's AI, sort of neurally enhanced. That's companion to the graphics processors. And this is
wait.
This is
Before
the
we
area
get there,
in which I'm sorry. Go ahead, Beth.
Before we get there, I just want to correct a piece. The RTX 5070 is the lowest end of that, and the 5090 is the highest end of that. The 5090 is 3400 AI tops, and it's 2000. And the 5070 is the much cheaper version, 1000 AI tops, and it's 550. Now that is just the card, right? But if you start at 2000, then your computer is much more expensive. Okay. Cool.
So I was going to say that NVIDIA is a player. It's the NVIDIA ecosystem spans a whole host of application spaces, and this what we're talking about right now is the gaming and content creation space that uses the GPUs like the RTX 5090 just announced to really advance and accelerate the capability of gaming platforms and games. One speculation is that games in the future will be generated in real time rather than following some model that was written by the game programmers. And you can see that in the video generation that's happening today, where there are some examples where a game environment is generated in the video, and it's in real time actually changing according to what the players in the game of the video are doing. So it's not a pre-planned space, where a shooter is going into this room and that room, but rather as the game progresses and there's text prompts that you can put in, you can change the action of the game and the environment is generated in real time. This hardware line, the RTX series, is the GPU center of that. But NVIDIA also at CES announced two advancements that are a part of their both hardware and software approach to this whole thing. And one of them is called NVIDIA Reflex 2, which reduces PC latency by up to 75%. And then the other one was DLSS 4, which is a neural rendering upgrade that generates additional frames for enhanced performance in the GPU presentation of computer-generated imagery.
And I want to bring in CJ Styles in our comments here has been giving us a little bit more information from maybe the gaming side. He says, deep research, the new GPUs are not that good, only like 5% in gaming area. AI has grown dramatically, but that's not helping gamers. He also mentioned that the 4090 beats the 5070. I'm not surprised to hear that. Again, I'm not that well versed in this, but we see that pretty often where the top of the line of the last, era that came out beats in performance in some ways the bottom of the line of the next era. We see this with like Windows Core. It'll be a newer fifth generation may be actually better than an older 12th generation or vice versa.
Sometimes. And I think that's what he means by the 490 being the 5070. It's more about because and he's right where he says that gaming and AI has kind of grown, but like the needs of a gamer are very, very, very there's pinpoint, depends on whether you're a console or your PC gaming or your Mac gaming. I don't go back gaming, but I mean, there are requirements and they're very fickle. So I think the thought would be, oh, we can render these worlds and it'd be awesome. And I'm like, yeah, that's a dream, because like if those worlds don't render properly and they cause issues, remote issues, you're going to hear it. You're going to hear a backlash of it. Like none of these things that came out, it's like, oh, this is in about 2 or 3 years, it's gonna be awesome. It's like, I'm not sure if you understand, like when things need to render in a way that's within microseconds for like just like a game like COD, Warzone, when your aim is off or something is off and it's because of the rendering, you're going to hear about it. So it isn't just, oh, it isn't like a Sora or a VO. It's like, oh, this is amazing. No. It has to be nearly perfect.
Yeah.
In less than 1 second, 0.1 second, or else it's not going to do what it's supposed to do. So I think that's where it has a long way to go. Same thing with AI, AI NPCs, AI, like they have very high standards on what the expectation was. So I think that's where, expectation versus what is available is still, that gap to me from an AI perspective is still a big piece. And then the fear that a lot of gamers have is, crap, are we going to get more like loot boxes, and are we going to have to shell out more because of AI this? And it's bolted onto the game now, even though we never wanted it, but now we have to pay $30 more for a game. That's also the added fear too.
Yeah. Do you feel like just coming from and being more in that world, do you feel like there's apprehension towards AI in the gaming world? Like it could mess up a good thing? Or do you think it's like, no, there's a lot of like the things we've seen are really kind of hacky. For instance, I've seen the real world building where, but if you do a 360, the stuff that you just passed is not there anymore. So you're facing a mountain range. But if you do a 360,
that's obviously gonna get you that will be it.
Right. Yeah. That doesn't really work really well if you're turning around as a character. But I don't know what's your take though on it.
And the gaming industry has been littered with like just crazy renders, like some weird things that just happen when you don't have the most, the highest end machines. Like the whole point is for a large number of people to be able to enjoy the game, ideally at a price that is reasonable without being tacked on as a DLC, without being tacked on as loot boxes. And then on top of that,
what's the DLC?
Oh, sorry, downloadable. So it's like, do you remember, like, let's take a game. So let's take, there was a game that one of my first games would be TIE Fighter, like way back, right?
Yeah,
it's a game called TIE Fighter. So let's say you have 7 missions in that game. Then they released, we have 4 additional missions, downloadable content. Oh, okay. I have to buy that.
Right.
What's happening in games today is you buy a game, but then immediately there's a downloadable content, but it isn't downloadable content. People are like, wait a minute, shouldn't that have been included the original game? So what's being released is like 85% complete, and the last 15, they're making you pay an extra $20 more. So it's literally like, wait a second, this is just money grabs after money grab after money grab. So instead of you paying $60, $70 for a game, you now pay $150, which should have been $70 to begin with. But with AI, now the developers potentially could have ways to do it. That's like, oh crap, it's $10 here, $5 here, and it's death by 1,000 cuts, right? You're like,
yeah.
I just shelled out how much for this game, and this game sucks. So that's kind of the thing that what? Yeah.
I mean, it's we've seen this with apps, right, for a long time. And not to get off the topic, because I know we're here to talk about NVIDIA's thing, but it is connected. I mean, what NVIDIA has been attached to the gaming industry, hand in hand for a really long time. So it is all connected, and it is important to talk about. Also, like I think we mentioned yesterday, the day before, the gaming industry oftentimes is a leading edge of what you end up seeing in other industries or other products. We were talking about movie making and how the Real Engine, I think it's called. Somebody told me in the comments yesterday, they're like, yeah, that's
it's Unreal Engine.
Unreal Engine. Thank you. Not Real Engine, Unreal Engine. I was like, it was just in the comments yesterday. Thank you, Beth. And talking about how Unreal Engine, how that's like being used in shows and movie making and things like that. We can talk about, like I said, we talked about we started to talk about digits. I'm curious to talk about that a little bit more because they call it Project Digits. That's what he said on the stage. And they talked about, I think, it being available as early as May. I think I have that. That might be the release date for that one. And essentially, it's a small CPU. It's maybe, I don't know. It's like the old, smaller than a laptop, but chunkier, like the old MacBook, whatever they were called. So they used to sit on the desk, the CPUs to it. But the idea that, what he was saying is like now all engineers, now all students that want all the power of NVIDIA could now either hook one of these up to a laptop or hook them up in a chain to get even more power from them. And I found that like really, really interesting that, these are coming, the power of these models and what NVIDIA is doing is coming to the desktop at perhaps a reasonable price. I mean, you could certainly see a university having many of these in a lab that allow students to work with and run models and stuff like that. So I found that really interesting as well, that this is going to probably hit universities first, I suppose, which is really cool for students to get hands-on learning. And then I don't know where it goes from that. Does a company buy one of those for their engineers? I don't know.
Well, remember, this is the one that looks like a Mac Mini. It's a desktop kind of little platform. It's a supercomputer in a small box. And this is not going to be, it's $3,000 for that little Mac Mini. It's not going to be a versatile universal application PC. It's going to be designed for doing AI training and inference. And so it makes it accessible for training models, just like the Mac Mini can, right? You can run AI training regimens on a Mac Mini or a chain of Mac Minis. And so this is their competing product for that. Now, when I first heard about this, I was like, oh, wow, I'm not going to buy another Mac. I'm going to wait until the NVIDIA computer comes out. Only $3,000. Well, it's really not as versatile a system as you might imagine. It's designed expressly for a purpose that is, AI supercomputing.
Okay, I'm getting confused because I thought the laptop Project Digits was the 3,000. Did they have two 3,000 items?
I thought Project Digits was the 3,000, designed for researchers and AI enthusiasts.
And that's the one they have an illustration of it that shows it next to a monitor, and it's the little Mac Mini type device. But I'm speculating a little bit here because we don't have specifications on it. But I'm saying this is not going to be a replacement for your desktop or laptop. It's a special purpose AI computer that'll allow researchers and hobbyists and so on to play with AI models and do their sort of
I'm curious to see, and maybe there's somebody who's going to do this, is buy it to game. I was like, I don't care about the researching. I don't care about the AI. I just want to see if it games correctly. And the thing is, sometimes some of these things, gamers just find really unique ways to use things, and it's like, wait a minute. And then it could be like, buy this computer for like the top of the line gaming because it's FPS 60 FPS is no problems, 120 FPS fantastic, and it's $3,000, like what you could spend if you actually knew how to build a computer, like parts and whatnot. You can spend definitely less to get a higher performance. But if you just want, like, I don't want to think about anything, $3,000 is not that crazy, especially from NVIDIA. And if it can do 200, if you can contain 200 billion parameters without any cloud infrastructure, that, if you actually think about that, translate it to a game, it's like, actually not a bad idea if like, you do a lot of gaming. So I actually will talk to a couple people and see like
Somebody's going to do it.
somebody's going to do it and
Yeah.
just to check it out, right?
Yeah. The 3,000 is definitely in somebody's price
Yes,
range
yes.
to F around with.
Well,
I'm just
I mean,
reading
and
on the article.
it's in the Mac price range,
I
right?
know.
I mean,
Yeah, it is right in the Mac price range.
I know. That's crazy. It
Ultra
says here
is
the super
saying
chip.
Ultra's
So
saying
go ahead.
it's
What
for
was the comment?
researchers. Yeah, researchers is a precursor for the AGI supercomputer, and it's for running AGI models, right? AI models that are open source AGI models. This is, I think, yes, the to move forward into something that could support your agents locally.
So it's saying here in an article, I have something on specifically on Project Digits. It says the device is powered by the NVIDIA GB10, which is like Grace Blackwell 10, I think, or 10, I think they say. Super chip, which houses separate linked components on a single chip to reduce the time it takes to move data between them. The super chip features the NVIDIA Blackwell graphics card and the NVIDIA Grace processor, packaged with 128 gigabytes of memory and 4 terabytes of SSD storage. Altogether, the device is approximately 1,000 times more powerful than the best laptops.
Yeah,
That's coming out of this article.
And Andy, you're right, because this is the thing that I'm showing on the screen now is the Mac Mini sized box that is the Project Digits. Cool.
And then you were talking, Beth, just because I have it in my notes and we could try to find it really quick. You were also talking about a laptop because I heard the same thing, that there's a 5070 laptop that'll be sold for $1,300. That was announced right in the same section when they first talked about the 5070 and the 5090 and that new series. They did talk about the 5070 laptop, and I can try to do a quick, see if we can get some views on that. 5070.
I think they mean that the 5070 series GPU will be built into a laptop at the $1,300 price range.
Oh, yes.
I don't think it means that there's a 5070 processor acting as a CPU in a laptop, but maybe.
Okay, say that again. You think it's just they're just talking about a laptop? See, I got the impression that it was like they were saying it was going to be an NVIDIA laptop, is the way running Windows.
Well, that may well be that NVIDIA is going to have a line of laptops if they don't already in some market that we don't have access to. I think, and again, I'm speculating, but I think what the 5070 plus laptop looks like is if the 5090 costs $2,000 just for the GPU.
Right.
Now try to find a laptop that's not going to cost $5,000 with a 5090 in, right? Like that. So a laptop has some, constraints that a gaming PC that's underneath your desk with 3 fans on it doesn't, right?
Right.
So what they're saying though is that you can get a 5070 GPU. This is a lower power GPU than the 5090. You can get one of those in a laptop at or about $1,300. And if history is our guide, then a lot of other players in the PC market are going to have a version of that. There may be one that's named NVIDIA, right? I think I'd be inclined to buy an NVIDIA laptop, just for fun.
I think you're right. I got that wrong because I was like, I thought the same thing. Like, oh, it's going to be an NVIDIA laptop. I actually found.
It looks like it. So Alter is saying again that this is the opening salvo for NVIDIA. They're coming for the consumer market for the regular uses. Yep.
Bring up my screen. I'll just zoom in a little bit because it's kind of tiny.
That is not your screen. That's mine. Here we go. Yes.
I'm going to zoom in here because it's kind of this chart. Can I scroll over a little bit? Okay. Well, even if I can't, right here on the side, the GeForce RTX 5000 laptop GPU series. And this is where it's actually talking about the laptops. And I guess, I don't know, it's what I pulled from the YouTube video summary and watching clips of it. So I probably got a little bit of this wrong, but it's talking about the different series of laptops. So what you said, Andy, and what we just got in the comments, I think is definitely more accurate for what they were referring to. And it also makes sense because you were talking about how, the 5090 starts at 2,000, but the 5070 was like what, 549 or something. So conceivably that could be in a $1,300 laptop. That sort of makes sense. So yeah, anyway, more or less confusion there. I'm not sure. I know it confused me because I was like, oh, there's digits and there's also a laptop. But I think you're right. It's just they're just talking about the type of laptop that would have that processor in it. So
okay, I want to pivot.
Please do. Wait.
Ooh, what happened?
They didn't put yourself on mute.
You wanted to pivot?
Thank you.
Let us have a moment of silence to enjoy.
Okay, I want to pivot a little bit here to from what we talked about at the outset, which is physical AI, which is autonomous vehicles and robotics, to AI computing, and also we talked about gaming and generative AI for imagery with the RTX series. And now I want to talk about another theme that was part of Jensen's discussion, which is agentic AI.
Yeah.
And so there's a bunch of different things that are part of the NVIDIA ecosystem that are related to agentic AI. And I'm going to name them first, but I want to focus on the Nematron models and the Llama Nematron model specifically, which was just announced. So NVIDIA has AI blueprints, which is for enterprise, basically. It's pre-configured workflows for creating custom AI agents that can analyze data, reason, and take action. They have NVIDIA NIM. NIM stands for NVIDIA Inference Microservices. And that's cloud native microservices for inference that integrate with NVIDIA blueprints, and NeMo, the Nematron models, for agent deployment. So you see this thing that's happening in the world of AI right now, where almost every company is moving swiftly towards agents. And NVIDIA has a whole suite of tools and systems in a platform, along with an agentic AI orchestration layer to deliver these agents. And what does that mean? That means agents that can replicate human performance within the enterprise. Right. So it's building that, not only the platform on which you run it internally inside the cloud or internally using the new lines of AI processors. So this is all leading up to the time when many roles in the company are going to be supplanted, maybe cooperatively with the humans, but supplanted by agents. Like some jobs that are done by humans right now, and the company will be taken over by agents.
I think that's a good. I want to share this really quick because how many times have we talked about, Karl? You were talking the other day about the definition of agents and how that's shape shifts a little bit, but he actually gave a definition. Jensen Huang did on the stage of agents, and I actually think this is probably my favorite definition. So I wrote it down because I wanted to share it because this goes right in line with what you were just saying, Andy, about Nemo and the avatars working for you. Agents, I'm basically paraphrasing, but this is what he said: a system of models reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. So system of models that reason about a mission, which we have the system of models. It's the reasoning about the mission that perhaps is missing a little bit. Break it down into task and retrieve data or use tools to generate a quality response. I actually really like that. It's simplistic, but actually in my mind, that's actually the definition I would like to use with my clients when I'm trying to explain to them that our current agents are really workflows, because the key part that I feel like workflows are missing are the reasoning about the mission and then knowing what tool through that reasoning to do. It's also why I talk to everybody and they're like, what can I had somebody yesterday say like, well, what can we be doing today? What could we be doing today as a company? I'm like, well, where do I start? But obviously I talked about data. You guys know I always start there. But one of the things I talked about is just simply getting clearer on what your tasks are. Because here you have them, the NVIDIA saying, hey, we're going to have these agents for you. These avatars are going to be able to do work for you. And I always say, like, the avatars may be able to reason through it and come up with the right tasks, but you're always probably going to be a little better off as the human if you're able to supply some of those tasks into the reasoning. That's definitely going to help you get a little farther, a little faster, especially when it comes to either whether it's retrieving data or picking the right tool for the job. And that may come in the form of, I don't know, examples or who knows. But anyway, that agent's definition is probably one of my favorites. What do you guys think about it?
I want to go. That definition is the ability to break down tasks. I also think the ability to, because right now from an like the automations that we're seeing, it's like there's a trigger. Either it can keep going based on certain triggers and then keep getting the outputs, but can it actually say, "Whoa, this"? And we've seen it with O1, where it, like, I haven't seen it in my use, but I've seen like screen captures of it where it saw its own mistake and went back.
Yeah.
So imagine if like this agent saw that the tasks it laid out, once it completed 3 or 4 of them, saw that, you know, task 4 didn't make sense or was wrong, it would change task 4. And you could see it make that change, go back, repeat, see it. And I haven't seen any system that has that ability, just that one ability to go back on itself and correct itself. So to me, that's automatically, it's like, whoa,
you're talking about, it's almost like constant reasoning is what you're saying.
Yes. Always.
Yes.
Like the output that I'm getting is incorrect or does not meet the entire goal. So
Well,
I have to.
We saw that with Baby AGI, and we saw that with what Hyperwrite created, a year ago when I was demoing that. I imagine
you could kind of see bits of it. Yes.
Because it would say, I can't open the file. Let me try it this way.
Yes, I will try it this way. But if you look at all the major AI automations, I haven't seen any of that type of like thinking, unless, I don't know, maybe there's a way that every single step you put in, think if this is the correct step, but that would just throw the automation completely off, right?
Right.
So yeah,
because those pieces that I think we're talking about are the result of it writing a quick Python code and executing a function that then it can say, this didn't work, we're going back. It does not, the reasoning piece doesn't do that as fluidly, right? Like one of the things that we started talking about way back in like Q-Star or like those precursor kind of stuff was that it would like play all possibilities of completing a task at the same time and then choose the one, right? But I'm not sure like that hasn't come to pass in the same kind of way, or they're not showing us when they say, hey, unfold your reasoning, show us everything that you did. It's not showing us that piece, right? But that was supposed to be the key.
You have a great point, Beth, and I'm curious about this, what you guys think. We see NVIDIA showing us how their processing power is getting faster and faster, and they're able to do near real-world computations as far as their black lookups and all that, right? Just think of all the stuff we just talked about in the last 38 minutes. I think you have a point, Beth, which is, and I didn't remember talking about it in that way, but that's where my brain was going too. Okay, we're thinking about agents as, let's just look at it. It's, okay, the models we got. It's a system of models. Multiple models, multimodal models, we don't know, but system of models. They're reasoning about a mission. But before it breaks it down into a task, and with what you're saying, Karl, about the continuous improvement, process improvement of the CPI of it with the reasoning, I think you have something, Beth, which is the future of agents, maybe not the near future, but the future of agents really is before it starts off on the first step after the reasoning is, I have computed 4 million different ways that this task could be accomplished. And I've come up with the top 5, and I will start with the first one and reason my way through if I get stuck. And that might happen all in the blink of an eye pretty soon. If the processing power on your computer is capable of running it at such efficiencies, you can imagine that if you had a multi-complex step, such as like the ones they always give that I think are always silly for agents, like it'll book a trip to Paris for you and do, you know, get you your tour on the river and you'll see the Eiffel Tower. And I think, I'm not giving it my money, you know. So I always think those are like silly, way future type things, like maybe someday, you know. But what I do see is for complex things about like finding the right prices, we know that's a very complex thing. We know that if you go back to certain websites or airlines, it might change, or hotels, it might change, you know, to different deals depending on, you know, when you go to it and what day and stuff. And so you can imagine an agent that is definitely smarter to go and figure out all the possible paths and then just run through them. And if you set it on like an open ticker and you said, well, I might want to take a trip in the next 4 months to Paris continuously or every day, I want you to run through this scenario again and always bring me back the best case scenario or situation for this, and then let it go forward if you decide that that's the right move. The purchasing and the credit card side of it and all that stuff, like actually doing the chip. That to me sounds like the actual future of agents, truthfully.
Mm-hmm.
I don't know. What do you guys think?
It all depends on your use case too. And maybe the thing that I want to point out is that the examples that we keep thinking about are still in the focus of what we do today. So I still go back to what Sam was talking about. It's like, well, you know, a lot of the examples are just us defining one specific task that this agent can do for us. So it's like book a restaurant, book my travel, which is has always been the example all the way back to GPT-4. Remember plugins? They use that example all the time. So now can we expand our scope where you're like, okay, I have 50 of these things. What can I do with 50 of these things? Or maybe reverse it, like kept talking about, and his definition of AGI was, hey, can I hire a remote senior coworker as an agent to go do this thing and come back and it's done or close to done? You know how like an employee works, you know, go back and forth, like, well, not quite, let's do this, you know, work together on something. But that's sort of how we think, and deploy multiple of those. How would our view of work and operations change if we looked at it from that point of view instead of focused on one individual task that we're currently doing today?
Right.
Yeah. Let me follow on this idea of multiple agents. And in my mind, when you say that, I think of it as, okay, I've got all these agents. I'm going to give them independent tasks. I'm going to send them off in their independent directions. But in fact, what NVIDIA's vision of this is that there's an orchestration layer that they've built that's a part of this agentic platform that makes sure that multiple agents function collaboratively within the enterprise ecosystem.
Yeah.
And so it's really that there will be specialized agents, and the orchestration of using this blueprints system, NVIDIA blueprints, and the models, the Nematron, the Llama Nematron, which is taking the Meta Llama open source model and adding agentic capabilities to it to allow for agents building there. And then for vision and autonomous robotic employees, if you will, that's the Cosmos Nematron model, because the Cosmos model is the one that has the vision capability and can act on its video feed, whereas the Llama cannot. Like Llama is not it's not capable of doing that kind of agentic reasoning, like what's going on here in this on the factory floor. But the Cosmos model is trained to do that.
Well, yeah, that's super interesting, and it makes me wonder about the natural speed of these things. We've talked about the way that things are starting to accelerate in a way that makes it hard to track. And in terms of what you're saying, Andy, and what Karl was saying, if we imagine agents in an agile system, Agile has daily stand-ups, right? So that you're going to come, you're going to talk about what you're going to do for 15 minutes because that's within the human capability workforce, right? And so then the human in the loop would be working at that level. Do agents, software agents, these sorts of things that have discrete tasks or goals, is that a stand-up that happens every hour, twice a day, every hour, every 15 minutes, right?
Yeah.
We are definitely getting beyond, in that scenario, we're getting beyond the ability for the human in the loop to just comprehend as much in terms of what's happening.
Right. Listen, I think you're absolutely right. That's exactly where it is. And Okay, you can, if I take marketing and sales, which traditionally should be always working more hand in hand, and we know a lot of companies that doesn't often happen. They get siloed from each other, and one hand doesn't know what the other hand is doing, but they truly should be working hand in hand, right? Marketing is pushing out plays, they're finding out what's working, sales should be coming right behind, so on and so forth. Well, I can definitely see this collaboration that you're talking about, Andy, and what you're saying, Beth, of where marketing is completely automated, because we can imagine in our minds some agentic workflows that are always constantly reevaluating, revising, and putting out new ads and taking down ones that aren't hitting, down to really, really niche different levels, right? Putting out that kind of marketing. And there's going to be response from that. People are going to sign up with emails, and they're gonna check out websites or whatever that future looks like. And then sales would be there. And you say, oh, that would be amazing, because then there would be this like just in time piece for reps to turn around to other companies and say, hey, I'm fairly confident, a high level of confidence that you are interested in this. But then where my brain goes from that, and not to get heady into it, is okay, but yeah, who is there to talk to? Because now on the other side, you have the buyer, and the buyer has all these agentic workflows that are always looking and are very understanding of what the company needs in order to make the next step. And they're always actively looking for the tool or the process that's going to make the process more efficient or whatever, which kind of makes you think, like, if this can all be done, to your point, Beth, every 10, every 5, every whatever, and that becomes cost effective, where exactly does the human fit? Because if companies can just talk to companies through agents, and at the point that the company needs the new process, like they're thinking about a new CRM, but there's actually no conversation about that. It's just the agents bringing it back to the people running the companies and saying, this has already been evaluated. We already know the best solution. And by the way, we've already talked to the people who deploy it. And by the way, we already know, like, it kind of takes the human out of the loop there a little bit, because it will always be near instant information at that level. And it kind of blows my mind when you get to that, because you start trying to figure out where humans plug back in, and you go, well, no, I don't need that conversation anymore, because that information got transferred and shared. And that's sort of like both the really exciting and interesting and scary side of agentic workflows for me, is where this goes in the future and how it squeezes out humans, just simply because there's no need for there to be that communication loop anymore between two humans. I don't need to communicate to you, Beth, that I need Salesforce. You already knew. And you don't need to communicate to me what it's going to cost. I already knew. So it's like,
And in 2024, Karl, we were talking about monkey fingers, right? So at some point that we're all working for our AI, because it's going to come back to us and say, hey, use your monkey fingers and do this, please. Yeah, like, we're skipping right over the monkey fingers. And now are we like, are we the like, government level 17, just hanging in the room until like, oh, okay, I'm in, put me in, coach, and you have a 5-minute task, right? Or you have
because I read today that there's a robotic hand now that can hold an object and simultaneously manipulate it, right? So it knows the physics of what it has to do in order to, like, imagine it doing a little juggling.
Yeah, I mean,
so
could be the
those monkey fingers are they're ancient history. Like they have one thing that those that the robotic fingers don't have right at the moment, and that is, a coupling between the sense of touch with multiple, factors in it, like pressure and temperature and, abrasiveness or friction. Like our fingers are very, very sensitive that way, and they're connected to our processor. Well, getting all of that is just down the road a little bit in robotics. Right? We will get there, but I'm sorry, Karl, but your monkey fingers will not be needed in the future.
No, again, we want to end this. Everybody knows what I'm going to be talking about. Can it pick up my recycling and go out and put it in there? That's really it. That's all we're talking about here. I think you can do that. However you do that, monkey fingers or not. That's what.
Come on, NVIDIA, get with it. Get with the recycling problem. I know you get all that stuff they're talking about CES. They didn't really hit what the real problems of the world are, which is, Karl and many, many other people.
I would love Jensen to go on stage, be like, we have solved one of the greatest problems in human history. is to taking out the trash in your recycling, and this is how we're gonna do it.
Well, listen,
And if he does it, I was like, how much does it cost? 200 grand. I'm like, sign me up, like immediately on there. I don't care. Have you solved that? That is the number one thing. You need to solve that.
I love that Greg will finish on this, but Greg's point was no need for recycling, which takes it to a whole other level. If AI takes us to a whole other level, that we've surpassed recycling. That's no longer a part of the process.
Yeah.
You know, I don't know if that makes you happy or sad, Karl, at that point, but it's if it gets eliminated from the system. All right, thank you to everybody in our comments. We're gonna wrap it up there. Thanks to everybody here today, Beth, Andy, Karl. Appreciated all the good conversation. This was a tough one for me. So like this was cool. And I think what's cool about all the conversation today is just how NVIDIA is so involved and will continue to be involved in all of these different areas, from robotics to the desktop computers or the sort of CPUs and so on and so forth. So keep coming back. Yeah, thank you to everybody in the comments. I hear people saying like, see ya. Have a great day. Keep coming back in the comments and being part of the conversation. We had a lot of great comments today. Very, very much appreciated to help us along with the conversation. Don't forget to like and subscribe if you like what you're seeing. Don't forget to come back tomorrow. We are here. If this is our first time ever seeing us, our group is here Monday through Friday, 10 a.m. Eastern. We haven't missed a Monday through Friday since we started. Well over 300 shows, now climbing towards 400. So we are here. We will be back tomorrow to talk more AI fun, good stuff, whatever it is. And we hope you join us and have a great day. Bye, everybody.
Yeah, tomorrow's AI at CES. So hope to see you there.